Hello, my name is Tim Amundsen. I'm a business development director at ScaleFlux. Today I'd like to chat with you about compression and some of the hidden benefits of compression. We all know that compression is used for storing and moving data more effectively. But compression is capable of so much more. Compression can be used to improve the consistency of our applications. It can be used to extend drive life. It can be used to decrease power utilization. It can be used to accelerate our databases and even enable new databases. Now let's start off by talking about latency. Latency being the measurement of time to complete a transaction. Latency directly translates to revenue. Here in this Computer Weekly article, it highlights that a 100 millisecond increase in latency resulted in a 1% decrease in revenue. And at Bing, if they saw a 2-second slowdown, it resulted in 4.3% decrease in revenue per user. So taking care of latency tails is extremely important. Now, latency is often plotted as a percentile or a distribution. With many transactions, we plot them out and we see something similar to a bell curve. Now, the median can be improved, and that's good, but more significantly, if we can take care of these tails, that's a more dramatic improvement and felt by the end user. We can take care of this in hardware. Now here, I am comparing the ScaleFlux 3000 series drive to a comparable PCIe Gen 4 drive, both of them at 7.68 terabytes. Using FIO, we wrote a 4 kilobyte 7030 mixed workload. Now, the IOPS number is significant. It's nearly 2x improvement. But how long did it take to get to that number? Using compression, we're able to achieve greater IOPS in less time. Now, this plot over on your left highlights the nines, and this is the probability of being complete by a certain amount of time. I took that and I did 1 minus that number so that I could plot it on a log scale. So 1 actually represents the 99th or 2 nines. Let's go one level deeper. So if we have 2 nines here, this goes all the way down to 7 nines. 7 nines, that latency is actually improved by little over 1 millisecond. What a significant improvement, all by doing compression on the drive for your customers. Now, compression is nothing new, and compression has been performed with a host CPU for a long time. And algorithms have been created to be more efficient in performing compression with a host CPU. And one example of this is LZ4. Now, as I jump to this other screen, I want to show you an example of a 13.8 kilobyte file being compressed. And LZ4 will perform compression and could get it down, theoretically, to 9.5 kilobytes. But there is a shortcoming. And that shortcoming is that it must write 4K aligned to the block device. And because it has to do that, it has to zero pad. And it has to add 2.5 kilobytes of just zeros onto the back of the file, resulting in a storage of 12 kilobytes. Now, with a ScaleFlux drive with compression inside of that block device, even if the file system writes 12K down, it will identify that zero pad. It will remove that zero pad and still store that file with 9.5 kilobytes. I want to show you an example of this. I took Hitchhiker's Guide to the Galaxy, a text file of it, and I performed some compression on it. I did an LZ4 compression on it, and I was able to get this decrease of about 60%, which is dramatic. But even when I wrote that to the scale flux block device, I decreased it even more. So that's about a 70% decrease overall. A dramatic improvement because of the compression performed on the block device and the fact that it can manage smaller sector sizes. Along with extending the life of the drives, writing less to drives also improves the available spare on the drives. On this plot here, I am showing a Postgres workload. And in Postgres, pages are 8 kilobytes. And the user may choose to fill that that page with full 8K, or choose to have a lower fill function. That is denoted on these plots here with FF equal 100 or FF equal 75, and that's 100% or 75%. We have a standard NVMe drive, and then we also have these ScaleFlex drives. So the blue and the gray are the standard NVMe drive, and then the orange and yellow are these ScaleFlex drives. And in each case, because we have available spare area on the NAND, the database will perform more transactions per second, will improve the overall experience of the end user, and will continue to service the drive for years to come. Compression can also be used to improve the power utilization of our systems. In these plots here, I am showing the energy needed to perform one operation, or microwatts per IOP. On the left, I have a set power budget of 16 watts, and on the right, I am trying to hit a performance target of about 200 K IOPS. With a set power budget of 16 watts, the ScaleFlex drive is able to achieve an IOP with just 22.7 microwatts, whereas a competing drive consumes 77.8 microwatts per IOP, over 3x increase. If I have a set power target, a set performance target, and I want to decrease my power as much as possible, we can do that with compression. Again, the competing drive consumes 77.8 microwatts per IOP to achieve 200 K IOPS, but the ScaleFlex drive with compression is able to do it with just 53.8 microwatts. Also use compression to increase the longevity of our hardware. Typical refresh cycles for a data center system is about 5 years. One of the primary reasons for needing to refresh the system is it no longer becoming reliable because the drives inside the system are wearing out. So if we increase the life of the drives, we increase the longevity of the system and thus save money and improve the environment. This particular application that I'm showing here is RocksDB. Now, RocksDB historically has a high write amplification, meaning though the database is small on NAND, there are a lot of writes and rewrites happening. And with every write of NAND, the cells wear out. And as they wear out, you need to replace the drive over a set amount of years. In this first column here, we're highlighting a normal, common commodity SSD. And we're using LZ4 compression on top of it. When we take that same, and the write amplification is dramatic. Here's the data from the database, and then this whole column is how many writes are performed for that operation. Now, as we also look at a drive with the ScaleFlex SSD, those writes are improved dramatically, a 33% decrease in writes. Now, even better, let's say we can turn off compression for RocksDB and only do it on that block device, only do it on that ScaleFlex. We get even more savings in decreasing our write amplification. And with every amount of decrease in write amplification extends the life of our hardware. The final benefit I want to highlight here that's often overlooked when considering compression is how it can unlock the potential of completely new and novel software solutions and data they're specifically written to leverage compression on a block level device off of the CPU. Here I'm introducing RocksDB. You'll see here that RocksDB is a tableless, hash-based key value database. Now this is very new and novel. With the ability to leverage offloading the compression, the physical space is comparable to what you would get with the very common RocksDB. But you can see that the logical capacity is about 2x that of what RocksDB can do, while the memory utilization is nearly 1/4. To store more data in less space and to have less memory utilization is an amazing benefit. But let's see the performance numbers. Here we're looking at different size data sets, 100 gigabytes, 400 gigabytes, and 1 terabyte. We're looking at both a write-intensive workload and a read-intensive workload. Blue represents RocksDB, orange wired tiger, and gray is the RocksDB. In every case, RocksDB is outperforming RocksDB. And it is doing that with less latency. Improvement in every case. As we look at reads, you can see that as the database gets larger, as the data set gets larger, RocksDB truly shines. Again, using less memory is important. And the latency is improved. In all, we can see that compression will enable software designers, database architects to write code that leverages compression offloaded to the block device. Zero padding is okay, because now the block device will strip out those zero pads and enable the database to perform with amazingly. Thank you for joining me as we've discussed together the benefits of compression, those far beyond just capacity, how we have discussed together performance improvements, latency improvements, power utilization improvements, even accelerating databases and enabling new and novel databases. I hope this has been informative for you. I invite you to research these. I invite you to get involved and reach out to us at ScaleFlux for more information about how you can offload compression into the block device and how you can see all of these benefits in real time, accelerating your solution, doing it more effectively, having a better total cost of ownership, and improving the experience for all of your end users.